Hello everyone, class 12. Topic is reaction of alcohol involving breakage of carbon-oxygen bond. Yes, in previous videos we have covered those reactions in which there is a breakage of oxygen-hydrogen bond. As you know, the general formula of alcohol is ROH. In previous videos we have covered these reactions in which oxygen-hydrogen bond was breaking and alcohol was showing acidic behavior. Now it's a time to discuss those reactions in which we have a carbon-oxygen bond breakage. Because this is R made up of alkyl group. It's an alkyl group made up of carbon and hydrogen, so carbon-oxygen bond will break in these reactions. Now let's check which reactions are involved in this category. Number 1, reaction with HX means reaction of alcohol with hydrogen halides. Reaction with PCl3, PCl5, PBr3, PI3. Number 3, reaction with SOCl2, thionyl chloride. And number 4, reaction with NH3, ammonia. On the surface of Al2O3 working as catalyst. First 3 reactions we have already discussed, where when we were doing preparation method of haloalkanes from alcohol, these 3 preparation methods were discussed with their mechanism. You can check those videos. Now in this video I am going to start this reaction. Let's go for that. Between alcohol ROH and NH3, a reaction is happening on the surface of a catalyst, that is Al2O3. Now before start of that reaction, I want to discuss some points with you. Like ammonia, this is the condition of ammonia. Nitrogen making 3 single covalent bond carrying a lone pair. This is ammonia. When hydrogen of ammonia, one hydrogen of ammonia is replaced by alkyl group, so it becomes 1 degree amine. It's a functional group, another organic compound it is, which is known as 1 degree amine. If 2 hydrogens are replaced by alkyl groups or even aryl groups like benzene ring, then it will become 2 degree amine. And if all the 3 hydrogens are replaced by alkyl group, then we will call it 3 degree amine. Because these products will be generated during this reaction, that's why it is important to have information about that. 1 degree amine, 2 degree amine and 3 degree amine. Now because this reaction is happening on the surface of the catalyst, so directly I am going to draw the surface of Al2O3 and I will show you the mechanism of the reaction on the surface. This is Al2O3, aluminium oxide. First of all, in aluminium oxide, it must be clear, aluminium is carrying vacant orbital with a +3 charge, one aluminium atom, and one oxygen atom is working as an oxide there, which is carrying 4 lone pairs around it, -2 charge. So these are the condition of these 2 atoms in Al2O3. Now, as this is the surface of Al2O3, so obviously these aluminium and these oxides are available on the surface. So here I have drawn aluminium and here oxide. Let me tell you, between aluminium cation and oxide there is an ionic bond. It's an ionic compound. So this I am rubbing. So on the surface of aluminium oxide, we have aluminium with vacant orbital, oxide with lone pairs. Aluminium sites are known as Lewis acidic site. Reason? Any atom with a vacant orbital have a tendency to gain pair of electrons. Such atoms are known as Lewis acids. Whereas atoms with a lone pair have a tendency to donate pair of electrons. That's why we can call them Lewis base. So this oxide is working as a Lewis basic site. Now, alcohol, ROH. This is a general formula of alcohol I am going to use here, ROH. Now, aluminium have a vacant orbital. So what will happen here? There will be, this is lone pair, and oxygen also carrying a negative charge because its electronegativity is more than hydrogen as well as carbon. So this lone pair and this vacant orbital will start interacting with each other. Means they will start to create dative bond. In this fashion, reaction will start. Due to which bond between oxygen and hydrogen will become weak, as well as bond between carbon and oxygen will become weak. This is positively charged, this is also positively charged because its electrons are toward oxygen and its electrons are also toward oxygen. But which will have more positive charge? Hydrogen will have more positive charge because between oxygen and hydrogen there is a more electronegativity difference as compared to carbon and oxygen. Carbon electronegativity we know 2.5 it is, oxygen 3.5, so difference is of 1, and hydrogen electronegativity 2.1, so the difference will be around 2.4. 1.4, the difference will be 1.4. So here we have more electronegative difference, means hydrogen will be more positively charged. Because hydrogen is losing hold on its electron, so don't you think around hydrogen vacant orbital will start to be generated? That vacant orbital will start interaction with oxide like this. Because this oxide have a lone pair, hydrogen is started to creating that vacant orbital, and that vacant orbital will start combining with this lone pair of oxygen. In this fashion, alcohol particle is making bond with active sites on a Al2O3. Now next what will happen? Finally bond breakage will happen. Obviously both electrons will completely shift toward oxygen and hydrogen will make bond with oxygen. So the next condition will be this. Between oxygen and aluminium bond will generate, and here R, and between this O and H bond will generate. And if I talk about charges, because this oxygen is going to use its lone pair to make dative bond with aluminium, so don't you think its charge will be +2 now? It was +3. After gain of 1 electron from oxygen side, it will become +2. Same condition is here. Now this O will become -1 charged because out of 2 electrons, 1 electron it will shift completely toward hydrogen for dative bond formation, and 3 pairs will left over there around it. 1 pair it has used to make bond with hydrogen. So 1 electron is completely toward hydrogen, so it will carry a -1 charge, and this hydrogen will have no charge because 1 electron was lost by it and 1 electron it has gained from this oxygen. So this is a condition. Now this R contains carbon. Obviously carbon and oxygen is more electronegative. It is carrying a partial positive charge. It is carrying a partial negative charge. In this condition, first of all let me tell you what we call it, RO. This is known as surface bound alkoxy group. Surface bound alkoxy group, OR, alkyl and oxygen alkoxy group, and because it is bounded to the surface of Al2O3 through aluminium site, we are calling it surface bound alkoxy group. This surface bound alkoxy group have carbon with a partial positive charge. Now there is an entry of ammonia, NH3. Because in NH3, as you know, nitrogen is more electronegative than hydrogen. So these electrons are more toward nitrogen side and carrying a lone pair. So it's a negative nitrogen over there. It will start attacking on R like this. Due to which, what will happen? Between oxygen and R, bond will break. Means carbon-oxygen bond will break. You will say, sir, you are discussing those reactions in which oxygen-carbon bond is breaking. But you have broken bond between oxygen and hydrogen. So they must come in the category of breakage of oxygen and hydrogen reactions. Wait. You will find out between oxygen and hydrogen bond is as it is. Only the bond between carbon and oxygen will break. Check, wait. Now when it will attack, this bond will break and obviously electrons will get shifted toward oxygen side. Now what will happen? Between aluminium and oxygen, bond is as it is, aluminium plus 2, and oxygen, because it is getting one electron of carbon to its side, minus 1 charge. This oxygen and hydrogen as it is, on this oxygen minus 1 charge is there, and R positive. Obviously this carbon will have vacant orbital because its electron has gone toward oxygen, vacant orbital and lone pair of nitrogen. They will combine together and what will generate? RNH3. This one. And between carbon and nitrogen there will be a dative bond because nitrogen has given lone pair to carbon for dative bond formation. In this condition, nitrogen will carry a plus 1 charge because one electron out of 2 electron, 1 electron it has completely transferred toward carbon, one it is carrying with itself. This condition. In this condition, nitrogen is highly unstable. What it will do? It will break bond from hydrogen, one of its hydrogen. And obviously electrons will get completely shift toward nitrogen because nitrogen is more electronegative than hydrogen. So from here, H positive will release out with a vacant orbital. This one. Now, this H positive will attack on this neighboring oxygen, O minus 1, this one. Due to which, from here, from this site, H2O will be released out, water molecule, and this site will become vacant. Here will we have vacancy, and let's write this H2O here, Al and this oxygen as it is, plus 2. Here we have a vacancy because from this side H2O is released out, this one. Now this vacancy will be filled by this oxygen. How? By breaking bond again from aluminium and it will become oxide. Already it is carrying minus 1 charge. It will break bond again from aluminium, so minus 2, and it will come here and it will fill that vacancy. So again we will have here O minus 2 like initially it was. Basic site. And what about aluminium? When it will break bond from oxygen, that electron will go with oxygen. So again the aluminium charge will become plus 3. So our catalyst will become in its original condition. Al carrying plus 3 charge, oxygen carrying minus 2 charge. What about this site? Let's check. Because nitrogen has broken bond from hydrogen, here there is a generation of this particle. Check this. What is this? In the start of the video, I have told you this is 1 degree amine. In this fashion, alcohol reacts with ammonia on the surface of aluminium oxide, and firstly it will generate 1 degree amine. And after the use of catalyst, you will get again the same sites. Now please check. OH bond was broken. OH bond was broken from here, but that H has made bond with O. So don't you think oxygen hydrogen bond is as it is? Oxygen hydrogen bond is as it is. Only the bond has been broken between R and O. That's why these reactions are in the category of breakage of carbon and oxygen. Finally check. After end of the reaction, oxygen and hydrogen bond is there as it is. Only carbon oxygen bond has been broken. This oxygen was from aluminium oxide. It has become H2O, and at the side of this oxygen, the oxygen of alcohol will come to fill the vacancy. This one. So in this fashion, 1 degree amine will generate. Don't think reaction is stopped. Wait. What this 1 degree amine will do? Because still it have active hydrogen. This is 1 degree amine. Still it have active hydrogens like ammonia have. What it will do? It will react again with second molecule of the alcohol on the same surface. Same mechanism will be repeated. On aluminium vacant orbital, there will be the alcohol molecule attack, second alcoholic molecule attack. Same -2 will make bond with H positive. Between oxygen and hydrogen bond will break. And between oxygen and aluminium bond will generate. Aluminium charge will decrease from +3 to +2, R as it is. O charge will decrease from -1 to -1. H will generate. Now here R will be partially positive. Now this will be attacked by 1 degree amine particle. These are H positive, these are H positive. It will be attacked again by 1 degree amine. So now what will happen? This bond will break. Electrons will shift toward this oxygen, due to which, first I will discuss this molecule. This molecule will become, when bond between R and O will break, both electrons will go toward oxygen. So vacant orbital around R means carbon, which will be filled by this lone pair of the nitrogen. So here we have dative bond, due to which again nitrogen will be in trouble, will get +1 charge, again unstable. So it will release again H positive. That H positive with a vacant orbital will again attack on this neighboring O negative, and what will release out? H2O. And what about this molecule? It will turns to nitrogen, will get lone pair on it, so +1 charge will finish. H is here, R is here. Watch carefully. What is this? This is 2 degree amine. And from here H2 will release, vacant site will generate, which will be filled by this oxygen, which will break bond from aluminium and will come here as O-2, due to which aluminium again will get +3 charge. So again your catalyst will be in its original form with the release of 2 degree amine. Wait, reaction is not finished yet. What will happen? 2 degree amine also have this active hydrogen, H positive. So reaction will be repeated third time with third molecule of alcohol, and same mechanism you have to follow, and finally you will get, try by yourself, this 3 degree amine, and your catalyst will be regenerated like this in its original form. There will be no change in the catalyst. Only on the surface of catalyst, reactants are coming, reacting, generating product, and they are leaving the surface. So catalyst will remain as it is. Just catalyst is providing surface here for the reaction through their sites, acidic site and basic site. Now, means in this preparation, in this reaction, we are getting mixture of 1 degree, 2 degree and 3 degree amines. Some 1 degree amines without reacting again with alcohols will generate. Some 1 degree amine will react with alcohol molecule to create 2 degree amines. Some 2 degree amines will again react with alcohol to create 3 degree amine. Some will not. So there will be the mixture of the amines generated on the surface of the catalyst. Now, if we want to understand this reaction in simple fashion, check here, very easy. CS3, CH2, OH. Let's understand it in a simple fashion also. This is, suppose this is alcohol I am using, this is ammonia. So very easy reaction. If we are not understanding through that mechanism, this is a trick in which you can learn it. Between nitrogen and hydrogen, which is more electronegative? Nitrogen. So electrons are toward that side. Hydrogen is carrying positive charge. Here we know oxygen is highly electronegative, so it is carrying negative charge. So H positive and O negative. They will combine. Bond between nitrogen and hydrogen will break and electrons will shift toward nitrogen, due to which CH3, CH2, H and nitrogen will be in this condition, negatively charged. Extra electron from hydrogen is on it, and this oxygen will become +1 charge because it is making dative bond with the hydrogen. So unstable. What it will do? It will break bond from carbon, and obviously electrons will shift toward oxygen. So from here H2 will released out, and this carbon you can assume as a carbocation, which will be filled by nitrogen. So what we are getting? CH3, CH2, NH2. This is 1 degree amine. This one. Now again, this 1 degree amine will react with second molecule of ethanol with the same mechanism. 2 degree amine will generate and H2 will release out. 2 degree amine will react with third molecule of ethanol. Again, 3 degree amine will generate and water molecule will release out. But 3 degree amine will not react further because it do not have active hydrogens for the release of water molecules. That's it. In this fashion, you can also understand that reaction. Try by yourself, and mechanism you also have on the surface what is happening. Thank you very much for watching the video.